Welcome to my channel once again. This is your man Alam, and today's tutorial we are going to dive into mensuration 2. That's surface area and volume of solid figures. And so without much ado, when we talk about mensuration, it simply means measurement. It simply means measurement. The act or process of measuring. So mathematically we can say that mensuration is a branch of geometry that deals with the derivation and use of algebraic expression and algebraic formulae to measure and compute the length, area, parameters, and volumes of various two-dimensional and three-dimensional solid figures. So that is the definition for mensuration. Then mensuration 2 actually talks about the surface area, volume of solid and the earth as a sphere. So spherical figures and solid figures under the surface area and the volume. In plane geometry 1, you may not have volume there. Okay, so let's do some comparison here. Mensuration 1 talks about the two-dimensional figures. And in that place, there's no depth or height. So we don't have height. They are flat surfaces. And they are only two dimensions. We only have the length and the width. An example is a rectangle. We only have length and width. Then we compute the measurement of only area and perimeter. There's no volume in mensuration 1, which we can also say that other topic, that is the angles theorem. So examples of the plane figures or two-dimensional figures are the circles, triangles, square, pentagon, and many others. Now, when we talk about the mensuration 2, it basically deals with solid or three-dimensional figures. And in this one, we have height, that is depth. And there are three dimensions: the length, width, and height. So anytime you are dealing with mensuration 2, you should know that we are dealing with these three dimensions: length, width, and height. In the two dimensions, we only have length and width, but there's no height. That makes it a two dimension. In the three dimensions, you have the length, the width, and the height. Okay. We compute the measurement of area, perimeter, and volume. In mensuration 1, there is no volume, but in mensuration 2, we have area, the perimeter, and then the volume. Now, example is the cuboid, the sphere, prism, cylinder, cone, and many others that are solid figures. Okay. Now, the combination of two or more two-dimensional figures form the net of a solid figure, which is the three-dimension figure. All right. So when the net is folded, we get a solid figure. Example, if we are considering the net of a shape, we say the net of a shape, which is also called a geometric net, is a term used to describe what a three-dimensional shape would be like if it was opened out and laid flat. So you see that this figure is laid flat like this. So it means it's a net of a three-dimensional figure. It is flat. When you fold it, you get a cone. Now let's look at the base radius of a cone. When we fold the net, we get our cone. That one that was flat, this one, when you fold it, you get a cone. When a 3D shape is unfolded, we get the net of that shape. Okay, but when it is folded, we get the three-dimensional figure. So 3D shapes can have more than one possible net. So let's take this picture for example. So this is a net of a cone. When you fold it, you have this. So you just fold it and you realize that A, B forms a circle under here. You have a new radius for that one. And this is a three-dimensional figure because now we have height, and we have the base. All right. Now, another terminologies we can look at is the curved surface area. When we talk about the curved surface area, we are referring to the surface or the area that is covering a three-dimensional figure. But to be able to understand that, we got to look at the flat surfaces. That's the non-exemplar, so that we can be able to get what the curved surface area is. Now, the flat surface are called plane surfaces. Example are the surfaces of a book, matches, box, table, and many others. So the surface, the flat surface. Example, we have this. This is a rectangle. We have a circle, a triangle, and these are also two-dimensional figures when you are looking at it. If you are looking at the table at the top flat part, it looks like a two-dimensional figure. Unless you are looking at a side way, you can see that it has formed a three-dimensional plane figure. But we are looking at the flat surface, so which is forming only two dimensions. We have only the height and then the width. So the surface which are not flat are called curved surface. An example are the spherical object. So this is an example. So this is flat, and the areas who are not flat are called the curved surface. Curved surface, right? And this is another example. Now, there are shapes which have both plane and curved surface. Example, have the cylinder, the cuboid, and so you have an example of a cylinder here, and this is a cuboid. Now, the region or area occupied by only the curved surface of a shape is termed as the curved surface area. So we have this the region we are talking about. This is a curved surface area. Now this one is the when you fold it, you have a rounded cylinder. Now the top and the bottom is covered by two circles, the lid. Now, when we are talking about the curved surface area, it is the one that you can fold. So this one, the rectangle here. So when you find the area of the rectangle, that's the length times the breadth, you are getting the curved surface area for the cylinder, excluding the circle, that's the lid, excluding the top here and the down there. What you calculate is the curved surface area of the cylinder. Now, when you come to the keyboard here too, all these rectangles or boxes, when you calculate this area, we have the curved surface area. Now, when you want to get a total curved surface area, it means I'm going to find all the area of the boxes and add them. Then I have the total curved surface area. Please stay tuned, and you can rewind the video as much as you want to get it very well understood. Now, the total surface area, like I made mention, is the sum of the area or regions occupied by the surfaces. Flat curves, okay? The flat curves. This is one. It's a curved surface, and this another curved surface. This another curved surface. All right. And the cylinder is just one curved surface, which is the one we have spread out here. So when you're able to add all this, we get the total curved surface area. Now, when you come here, this one out and this one out. When you add the area of this circle here, which is pi r square, and the area here with this, you get a total curved surface area for the cuboid. All right. Now, these are examples of three-dimensional figures. We have the cube, we have the rectangular prism or the cuboid, we have the cone, and these are their nets. So to find the area of the cone, you will need to get the base area, that's a circle. The base place is a circle. So you find the area of the circle, then you find the area of the sector, then you add it together to get the total surface area for the cone. Likewise, you do the same to the cylinder. Okay, so these are other plane figures. You have the cube, the cuboid, the triangular prism, the pyramids, and that's by the way. Please, if the video has blessed you, don't forget to leave a comment so that I can improve upon it. Subscribe and share, and don't forget to like so that YouTube can promote my videos to a lot of audience.